Hi friends, welcome to my channel. I hope everyone is doing good. Today we are going to solve a Leetcode problem 621 task scheduler. This is a very popular medium complexity coding problem and this is quite interesting problem. I recently came across this problem and I would like to discuss this problem with you guys so that you can also understand the logic how we can solve this kind of problems and implement its solution. If you are new to this channel, please subscribe to this channel now. Your subscription is really valuable and important for us. It really helps us, helps the channel as well as supports the channel. So let's start with the problem statement. Then I created some nice examples for you guys so that you can clearly understand this problem. So let's start. You are given an array of CPU tasks, each labeled with a letter from A to Z and number n. Each CPU interval can be idle or allow the completion of one task. Task can be completed in any order, but there is a constraint. There has to be a gap of at least n intervals between two tasks with the same label, right? So it means that you cannot execute same label task in that time frame, right? Return minimum number of CPU intervals required to complete all tasks, right? So this is what the problem statement says. So they have given some examples. So if you take a look at this first example, so there are these tasks A, and B. So n is equal to 2. It means that after A, so you executed A, you cannot immediately execute A basically, right? You can execute B, then you have to be idle for one time and then you can execute A basically. So it means that you have to have this gap of 2 basically here, right? And then you can execute A. So that's what the n is 2 means, right? So this gap should be there basically, then only you can execute. So how earliest basically, or what is the minimum number of CPU intervals is required, that's what they are saying. So in this case you can see that you executed AB, then you have to be idle for 1 minute. Let's talk like, let's say 1 minute, right? Then again you can execute AB, again you have to be idle for 1 minute because you cannot execute a task for at least n intervals, right? N is 2 here basically, right? And then again you can execute AB. So it means that totally how long, how much it takes you? 8 intervals it took you basically here, correct? So that's what we want to find out. Okay, so here is another task. You have A, C, A, B, D, B, right? And n is equal to 1. So in this case you can execute A, B, C, right? And then D, B, A, right? So n is equal to 1. It means that you have to have only gap of one interval there, right? So with a cooling interval of 1, you can repeat a task after just one other task, right? So there should be only one task in between basically, correct? So that's what it means. So it will take 6 intervals here, right? Now this is another interesting example they have given us. It's similar to the first example, as you can see, first example, but n is equal to 3. It means that the cooling period should be 3 basically here. So it means that once you execute AB, you have to be idle for 2 minutes here, right? Or 2 intervals, right? And then again you can execute A, because you see you executed A here, then you should have a 3 intervals here basically. So 1, 2, 3, and then only you can execute A. Again you should have 3 intervals here and then only you can execute A, correct? And then B. So totally it took you actually 10 total intervals, right? So this is what they are saying. Okay, so this is what they are saying. So let's talk about like this one example. So let's say let's discuss the general approach, how we can basically solve these kind of problems, right? So we want to minimize the time. So let's just first I'll give you one general example. Let's say A is equal to 5, right? A is equal to 5. So a task, let's say, takes 5 minutes and this task takes 1 minute to execute. We are talking about in general, right? Not about this exact example, but you can consider that this is the time each task take. Okay, and means basically you want to minimize the time, right? So if you, let's say, means it takes 5 minutes task or 5 minutes interval you have basically, right? So if if you basically execute the task, uh, a appears 5 times, right? A appears, what I mean to say is a appears here 5 times. So a and a, right? So a appeared 5 times here, and other b c d e appeared 1 time, right? Now if you want to finish this task earliest, right? So now and your n is equal to 1, let's say, right? Then if you start b c d e first and then you start a, right? Then you start a. So let me just remove this color. uh, okay, so if I start b, then I started c, then d, and then e, right? Now I can do a basically, right? Okay, now I have to wait one interval, basically n is equal to 1, right? So it means that I have to wait one interval here, then I can do a, one interval here I can do a, correct? Like this basically, because one interval should be there empty, right? Because n is equal to 1 according to what they are saying. So this is a. So how much total time it took me actually? So 1 2 3 4 5 6 7 8 9 10 11 12 and 13, right? So 13 it took me the time basically, correct? Okay, now if I do, instead of that, if I do, let's say a first, right? And means if I start with a, my point is that if I start with a basically, right? Then I do b, let's say a b, then again I put a, right? Then I put c, right? Then I put a, right? Then I put d, then I put a here, and then I put e here, right? So how many a's are there? 1 2 3 4, and now one more 5 I will need, right? If I do that, if I start executing my task with this a first, right? A. So then how long it took me? 1 2 3 4 5 6 7 8 9. So it took me 9 minutes or 9 intervals, right? So it is far smaller than this one basically. You must have understood this, right? So what are we doing here? We are greedily choosing the label or the task which appeared maximum number of times here, right? So a appeared maximum number of times. So a appeared 5 times, b appeared once, c d e all appeared once. So if we choose the task which appeared maximum number of times, we should execute that first basically, right? We should start with that task first. If we do that, then we can minimize the execution time basically, right? Because that is what our intention is. That is what our goal is, minimum number of CPU intervals required to complete all tasks, right? So okay, so now I hope you understood this idea with this example, and I explain you why we should also do that. Because we if you don't do that, and if you let's say start with this task a, which is the maximum amount of task at the end, right? Then it will take you more time. This is obvious, right? Because you have to keep waiting here every time you have to wait for that one interval which you have wasted basically, right? But if you start with a, I don't have to waste interval. I can execute b here, then a, then in this interval I can execute c, because I cannot immediately execute a after a, right? Because that cooling period we have to wait. We cannot execute that same label in that cooling period, right? So after c I can execute a, in the cooling period I will execute d, again a, then in the cooling period e, and after that a, right? So it gave me 9, which is just far smaller than 13 basically, correct? So this approach is called as a greedy approach. So we are greedily choosing the label or the task which appeared maximum number of times first, correct? Okay, so now you understood that. So with this example, here is another example for you guys. So in this case, so these are the tasks which are given to us, and if n is equal to 5, it means that the cooling period is 5 basically, correct? Then first what we will have to do, we will have to find out the frequency of each task, right? How many times that task appears. So if you calculate the frequency, then A appeared 3 times, B appeared 3 times, C appeared 2 times, D and E appeared 1 time, right? So these are the frequencies of the task, correct? Okay, so now we know the frequency. It means that now I can decide which task I should execute first. Maximum frequency I should execute first, correct? So what is the maximum frequency here? B or C? Oh, sorry, A or B? both anything you can execute between A and B because both has maximum frequency. So what we will do is we will put all these things, all these values of frequency in a priority queue. Priority queue is a maxip, right? We will use it as a maxip. So priority queue is a class in Java. So I'll show you that how to use it. So in this case, what you will have in priority queue, you will have these things 33111. So this is what you have in priority queue in the beginning because you put that frequency, right? And the maximum it will keep it on the front basically. So what you will have 211, right? 33211. So 211. So this is what you have in the beginning. This is, let's say, your priority queue. Okay. So maxip, right? Okay. So this one should be 2. Okay. This one should be 2. Okay. So after that, what we will do in the first cycle, we will start executing. First we'll start with A, let's say, right, because it has maximum frequency. So A, B, so what we did, let's say A, then I executed B, then C, D, E, correct, C, D, E. So I executed this because I can do that, right, all different labels. Okay, and then I will reduce the frequency here, right. So what will be the new frequency, right? The new frequency will be 2, then here also 2, and here 1, and this one will be 0 0. So I will not try it, right, because it's gone basically. You are done with those tasks D and E, you already executed them, right? Okay, so how much time it took us? 5. So I will just say time, but it's basically intervals, right? Okay, so next time now I can execute. So now I can execute, let's say, another task here. So let's say what is the another task remaining now here? C is remaining, right? C is remaining. C is the A2, B2 and C1. So C I can execute here because cooling period is 5, right? I cannot execute A here, but I can execute C, correct? N is 5, and then I can execute A and I can execute B. You agree with this, right? So cooling period is 5, means 1, 2, 3, 4 and 5. So 5 different tasks are there, means, and then I can execute the task A. I cannot execute A before that because cooling period is 5. Okay. So now you executed CAB. So now what you have here 1, 1 and 0. So 0 means, let's just write down 0 here. Okay. So now you only have A and B left, and how much your time is gone now. So after this A and B, you have to keep waiting for how much time you will wait? 1, 2, 3, right? 1, 2, 3, and then 4, basically 4 here, 4. Because your cooling period is 5, it means that you cannot execute the task A now until 5 times. So 1, 2, 3, 4 and 5. So after this 5 times, you will execute A and you can execute B basically, correct? Okay. So if you calculate this total, so 5 plus, so 6, 7, 8, 9, 10, 11, 12, 13 and 14. So 14 is your answer. So total actually the intervals it took you are 14 to complete all the tasks, because next time here you will execute it and it will become 0, so nothing will be there in the priority queue, right? 0 we don't put basically in the priority queue. Okay, so this is the way we can approach and solve this problem. So I hope you understood this approach clearly, and you also understood why it is, because I explained you why it is, right, with this example, why you are greedily choosing that maximum frequency so that you can finish it earliest, right, or minimum number of cycles basically, right? Okay, so let's just do a quick recap what we are going to do. So we are going to go through this task array. We are going to calculate, like create the frequency array so that we know for each task how much is the frequency for each task. Then we are going to take all the values of the frequency and we are going to add those frequency into our priority queue, and then we will start iterating and processing the task, simulating that the tasks are being processed, and we will also make sure that we will wait for that cooling period here, whatever is the given, right? And once the priority queue becomes empty, it means that you are finished with all the tasks, and that one will give us the answer, right? Okay, so let's take a look here. So list interval is the method we are implementing. Task array is given to us, and n is given to us. So we will create one frequency map of character comma integer. So we will create one frequency map of character comma integer, and then we will So for each character, what is the frequency of that character? That's what we want to calculate. So that's we are going to calculate in this for loop. So you will go through the task in the for loop. For each task, you will create the frequency, right? So this is the way you can create a frequency map, right? So this is the standard way. So get or default method, what it does is if you don't have the entry there, then it will give you 0. If you have the entry of frequency, it will give you frequency, and after that you will add 1 to it, correct? So you are incrementing the frequency. So now you have the frequency map ready. I'll show you here. I will just print it for you and then we'll remove that. Okay. And priority queue is what is we are defining here, which is a maxip implementation we are going to use, right? Maxip means because maximum frequency we want to keep it on the top, because that is the task that we should execute first. For example, A we should start with first, right? Because it has maximum frequency. That's why it's a maxip, right? And we are going to all add the frequency values from our frequency map into the maxip here. After that, we'll create one variable is CPU intervals. It is 0 in the beginning. Now, while there is while there is some elements in that maxip, right? It's not empty. Then we'll keep processing it. So you will just create one temporary list of integers here, which is an array list. And what we will do, we will have a for loop which will go from 0 to n plus 1 I plus plus, because you remember that cool off period. That's why we are going to go to I is less than n plus 1, correct? What we will do here is we will remove the frequencies, right, from the 10, right, from the maxip, and we will add it to the 10, right, the frequencies. And after that, here we will go through each of that frequency and we'll reduce that frequency and add that reduced frequency into the max heap. So that's what we did here, right here. So first you will have the frequency 33211, correct? Let me choose a pen here. So this is your first frequency. Now what we are simulating is we are executing the task, right? So first you executed A, then B, then C, then D and E, right? So you are reducing that frequency by 1 for each one, correct? And again adding that into the priority queue, correct? So that's what. So you reduce that frequency which is in temporary. We added that temporary we have frequency, right? Maxip.remove will give you the frequency into the temp list, and you go through each frequency, you reduce it and add it back to the maxip only if it is greater than 0. That greater than 0 is important, right? We don't add a 0 thing there. Okay, all right, then we will just print a maxip for you here. And after that we will keep track of how much CPU intervals it took us basically for that, for this while loop cycle, right? So if maxip is empty, then whatever is your temporary size, that is what you will add to your CPU intervals for the last time, right? For the last time, or you will say n plus 1, correct? Or you will say n plus 1, because for example every time you will execute n plus 1 tasks, right? So because of the cool off period, right? Cool off period. So what I mean to say is when you execute this a b c d e and then A and then C, then this one actually is total what you are going to add here, right? So n plus 1 you will add into CPU intervals, right? So only if your max heap is becoming empty, you will add the temp size. This will happen only for the last time. For example, when you are executing this last AB, you will not add 6 here. So here you will add 6 n plus 1. Here you will add 6 n plus 1. But here you will not add 6. Here you will add only 2. That's how that 14 came, right? Because you are done basically after this AB, right? That's why. Okay. So you are in a while loop. You will keep processing your max heap, which is nothing but a priority queue, and at the end you will just return the CPU intervals, and that will give you the minimum number of CPU intervals required to complete all tasks, right? Okay, so I hope you understood this. So I am going to run this against test cases. I'll show you how how the frequency map look like, and then we'll submit it. So for example, you will see that this is the frequency map, right? So A appeared 3 times, B appeared 3 times. This is how priority queue is being processed. So first it was 3 3, but we did not print it. After that it got reduced to 2 2, and after that it got reduced to 1 1, and after that it became empty, correct? Because every time you have executed one of the tasks, correct? You got it, right? So that's how it works, right? So here A appeared 2 times, B appeared 2 times, C appeared 1 time, and D appeared 1 time. So this is how the so first you have 2 2 1 1 there, right? 2 2 1 1. Then you will be like A will be reduced, B will be reduced by 1, right? And then again reduced by this 2 will be executed, so only 1 1 will be left. So like this, right? So 6 total cycles it took you. Okay. So let us remove that system out or comment it out for now, and then we'll submit this code. So that was just to show you. So we'll submit it now and make sure the code is getting accepted by the Leetcode. And as you can see on the left side, the code is accepted by the Leetcode. It is 35.48% faster than than other submissions. Which is pretty clean solution based on the Maxip implementation. So make sure you go and check out the priority queue class in Java. It's very important class to solve these kind of problems. And you should know there are two benefits of priority queue. You can use it as a maxip, you can use it as a min heap as well. So in this case, since we want the maximum on the top of the queue, then we have used it as a maxip, right? So this is how you can solve this problem. It's on Leetcode 621 task scheduler. So I hope you understood this with this example that I created for you guys, and you understood the logic also completely why we have done this way, so that you can also explain that in interview, and that should help you in the interviews to solve these kind of problems. If you like these examples and this whiteboarding session, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. It takes a lots of efforts, guys, to create these examples, to explain these examples, and to create these videos. So if you really want to appreciate our efforts, and so try to be generous, give it a like to this video and subscribe to our channel. Your subscription really helps and supports this channel. On this channel, we create content to help others in their coding and Java interviews. Click on the bell notification icon button right away so you won't miss any important postings from our channel. If you are planning to take any interview rounds, or you want to learn more computer science related concepts and algorithms and data structures, then there are very important playlists for you on this channel. Uh, you can check out the playlist for graphs, matrices, binary search trees, binary trees, how to solve different problems related to binary search, dynamic programming, memoization, recursion, as well as important data structures problems such as stacks, queues, priority queues, min heap, max heap, how to use and apply BFS and DFS on graphs, matrices, and trees. So everything is explained here with examples, so that you can clearly understand and follow the computer science concepts and build up your logic that is required to tackle different interview questions. Go through them. You are going to learn a lot by watching those videos for sure. And share these videos with your friends so others can also learn from this channel. Keep learning, keep coding, keep solving more varieties of coding problems. And thanks for watching this video, and have a great day ahead.